All right, today we're going to talk about one variable word problems, and there's a whole bunch of different varieties, so I'll just go through some examples. So this is what we'll call the pool problems. So it'll be typically something like this. In a backyard, I have a pool with the dimensions 12 feet by 20 feet. I'm going to surround it with a walkway of uniform width. The total area of the pool and the walkway is to be 400 feet squared. What will be the width of the walkway? So what we have here is we have a pool, and they tell you that it's 12 by 20 and it wants to have a walkway of uniform width, which means that this width here, I don't know what it is, but this width here would be X. This width over here would have to be X. But going up this way too, it has to be uniform. So this here would be X and this here would be X. So all the way around, it's going to be X. And they tell you that it's 12 by 20. And again, those are all X's. I'm going to say X is my width of my walkway because that is my unknown, and that's what we're trying to solve for. So I can write an expression for this length. This length is 20 plus X and X. So 20 plus 2X would be this whole length of this pool and the walkway. And the other way would be 12 plus 2X because I have X here and X here. They tell me that the total area of the pool is 400 feet squared. So I can write an equation. I can now multiply this all out. I can subtract the 400 and set it equal to 0. And then I can divide through by 4 to make it a simpler equation. Now that I'm going to look at this equation, and I'm either going to see if I can factor it, or if I can't factor it, I'll try and solve it by the quadratic formula or completing the square or some other convenient method. So this one does not factor, so I put it into the quadratic formula. And when I simplify it all, I'm going to get X is 2.2 or X is negative 18.2. Now again, because this is a word problem, I'm going to put this in my calculator and simplify it because it wouldn't make sense if I said it was, negative 8 plus or minus the square root of 416 over 2 or something like that. That wouldn't make sense. So go ahead and put it in your calculator and get a decimal. Of course, the width cannot be negative, so I'm going to throw away the negative answer and only keep the positive. So the width of the walkway has to be 2.2 feet. All right, let's take a look at some right triangle problems, which could be either the area or the Pythagorean theorem, or perhaps a combination. So this one says the sum of the legs of a right triangle is 15 inches. The hypotenuse is 12 inches. Find the lengths of the legs. So here's my right triangle. It tells me that the hypotenuse is 12, and I'm going to call one side X. And if I call one side X, I can call the other side 15 minus X because I know together that they are going to add up to 15. And remember, these are one variable word problems, so I want to try and stick to one variable. So I'm going to say X is one leg, 15 minus X is the other. I can set up my Pythagorean theorem, expand it all out, combine my like terms, set it equal to 0. And once again, I'm going to either factor it or use the quadratic formula or some other convenient method. In this case, I'm going to use the quadratic formula. Again, I'm going to put it in my calculator. And now I get 11.5 or 3.5. You can see that if I pick 11.5 and I say 15 minus 11.5, I'm going to get the 3.5. So that tells you that the two legs are 11.5 and 3.5 inches. All right, here's another example. One leg of a right triangle is 3.2 centimeters longer than the other. The area of the right triangle is 46.3 centimeters squared. Find the lengths of the legs. So once again, it told you it was a right triangle. I want to find the lengths of the legs, so I'm going to pick one leg and call it X. The other leg I know is 3.2 centimeters larger than the first leg, so I'm going to say that's X plus 3.2. And it tells me what the area is. So if you remember the formula for the area of a triangle, here I'll write it up here just to remind you. The area of a triangle is going to be 1/2 the base times the height, where I can call this one the base, and then this one here would be the height. So, whoops, that's an H. So I'm just going to put that into my formula. 1/2 the base is x, the height is x plus 2, and it tells me it has to equal 46.3. So now, once again, I'm just going to simplify the equation. I'm going to multiply it out. I'm going to multiply by 2 to simplify the equation, get rid of the fraction. Subtract the 92.6, put it into my quadratic formula, and get an answer. Again, I cannot have I'm going to get rid of this so you can get it out of our way. I can't have a negative length, so I'm going to throw away the negative answer, and I'm going to have 8.2 as my answer, but when I add 3.2 to that, I'll get 11.4 as my other one. Consecutive integer problem. So consecutive integers are like 1, 2, 3, 4, one right after another. So I can use them saying it's x, x plus 1, x plus 2, and so forth. For instance, if x was 3, the next number would be 3 plus 1 or 4, and then the next number would be 3 plus 2 or 5, and so on and so forth. If I have consecutive even numbers, it would be x, x plus 2, x plus 4. So if I picked any even number 4, I would have to add 2 to get to the next even number, or add 4 from the original number to get to the next even number, and so forth. And the same thing with the odd numbers. I'd still have to add 2 because I'm jumping a number every time. So if x was 3, the next number would be 5, which is 3 plus 2. And the next number would be 7, which is 3 plus 4. So if it says find 3 consecutive even integers such that the product of the first and the third is 20 more than 10 times the second. So that's a lot to wrap your head around. So let's start first by just saying x. So they said 3 consecutive even integers. So I'm going to call the first one x, the second one x plus 2, the third one x plus 4. It says the product of the first and the third. So the first one is x, the third one is x plus 4. The product means multiplying them. So I'm going to multiply those two together. And that has to equal, the word is kind of means equals, 20 more than, so I have to add 20 more than 10 times the second. So the second one is x plus 2, and I have to multiply that by 10. So here I have an equation. Once again, once I have an equation, I can just multiply it all out and simplify it. Put it into my quadratic formula if it doesn't factor. And I'm going to get 10 and negative 4. Now, the fact that I got whole numbers like that tells me that it was factorable, so I could have factored this if I had wanted to. So my two numbers would be 10, 12, and 14, but it also could be negative 4, negative 2, and 0, because in this case, negative numbers are okay.